Alright, so I know you guys have questions,
40.
so let's do it now. And I believe there's one problem on last night's homework where you use your graphing calculator to make the number line. Did you do it? Yes or no?
Yes.
We go to 41. 41, 55, 56. Any questions on the mean value theorem? You guys know how to do it? Okay, so 41. Are you serious? What about the one where you use your graphic calculator?
Number 6.
Number 6. Okay, number 6, that's the mean value theorem. I'm surprised you didn't ask that earlier, since that's an even number. Okay, it says find the value of C that satisfies the mean value theorem.
Number 3.
Anyway, of course, the mean value theorem will apply here because this is a differentiable function. You guys know what the graph of natural log x looks like, right? It's like this. It's a known graph. It looks like this. It's all smooth and continuous as long as x is greater than 0. And then you're going to shift it 1 to the right. Anyway, so the mean value theorem says there's at least one value of C somewhere between here such that f prime of C is equal to f of B. Have we memorized this yet? All over B minus A. This is A and this is B.
Yes.
Okay, so the first step is you need to take the derivative and plug in C. So the derivative of natural log of x minus 1 is what? 1 over x minus 1 times 1. So if you plug in C into that, you get 1 over C minus 1. And then you need to compute f of B minus f of A over B minus A. Well, B is 4 and A is 2, so this is 4 and this is 2. So what is f of 4? Plug in 4 into the function.
Natural log 3.
Natural log 3 minus f of 2, plug in 2. Natural log 1, which is 0, all over 4 minus 2, which is 2. So all you have to do is solve for C in this equation, and that's the value of C that satisfies the mean value theorem. So, what do you want to do to solve for C?
Oh, gosh.
This is what I would do. I would reciprocatize both sides, and then add 1.
Yeah, we got that.
Wow.
Yeah.
And of course, if you want to punch that in on your calculator, you can, but
I have no
you're not going to have a calculator, so you just leave it like that. Blakesley,
None of my problems match what's in the book.
then you better ask questions then.
Well, no, like,
Okay, that was already said.
never mind.
55.
Okay, what about, so everybody can do 27 then?
Yeah.
Blakesley? Yeah, you have to use a calculator to make the number line.
I think I did the wrong page or something.
Well, do you know the point? The
You gotta get the x and y coordinate, right?
Yes.
Okay, let's do 23 then.
Okay.
23, y equals x times the square root of 4 minus x.
See, that's not what my 23 is.
Okay, so what we need to do is take the derivative and make a number line. So did we get this? That's like to the 1/2 power, yeah? So they're using the product rule. Did we use product rule?
Yeah.
Times 1/2 box to the negative half times derivative of box. Did we remember that? Oh, what's the problem? So what do you want to do? You want to
Number
simplify?
line.
No, you can't make a number line yet. You got to
No, I
simplify.
have a hard time.
Okay, so what can I factor out here?
4 minus x to the
I can factor out a 4 minus x to the
negative.
-1/2, but you also should factor out a fraction as well, right? If there's fractions, you should always factor out the least common denominator. And then what's left?
4 minus x.
2 times 4 minus x minus.
X.
So look, some of you are so befuddled. It's like, if you have a hard time working with these fractional exponents, then you know what I say? Change it back to radicals. Like, why don't you just change this to root 4 minus x over 2 root 4 minus x. Why not just change it back to radicals like that if you can't factor it? That way you can see the least common denominator is going to be what? 2 root 4 minus x. And what's going to be on the top? 2 times
4 minus 6.
4 minus x, which is equal to 8 minus 2x minus x, which is equal to 8 minus 3x over this. Or if you do it this way, look, if you simplify what's in the brackets here, you get 8 minus 2x minus x. Isn't that the same thing as that?
Yes.
Yeah, so I don't care which way you do it, but you gotta do it.
I realized what I did.
What?
I did the 5.3 with the numbers that you assigned for 5.2.
So you did 5.3.
Yeah, but the numbers that you had assigned for 5.2.
Okay, now we need to make a number line. What goes on the number line? 4
Over.
and 3/8. No, 8/3. 8/3. Okay, think of a number bigger than 4.
5.
Plug it in. No can. Because look, this is like square root. If you plug in 5 here, 4 minus 5 is negative, you can't square root a negative number. That's not even in the domain of the problem. Okay, plug in a number here. What's a number bigger than 2 and 2/3 but smaller than 4? 3. Plug in 3. So 1/2 is positive. That's positive, but that's negative. Negative. So plug in a number here, like 0. You plug in 0, positive. They're all positive. So that means y is increasing over here. Y is decreasing over here. So if you have a function that only goes up and then down, and that's all it does, isn't this the absolute maximum right here? So the absolute maximum will occur at 8/3, comma, and how do you get the y coordinate? You plug it back into the original. So that would be 8/3 times the square root of, what is 4 minus 8/3? What is 12/3 minus 8/3? Square root of 4/3, and I will let you simplify that. Because the square root of 4 is 2, right? What? There's no calculator on these problems. Like if it comes out like really bad, then yeah, you use a calculator, but no, there's no calculator for this problem. The only one you should use a calculator on was number 27, because it said GC on it. Hey, over half the AP exam is no calculator, you know. You guys gotta get used to that. Okay, now we do 41. Now, what they want you to do is they want you to draw a sketch of a graph that has these properties. Okay. Let me get the book here, 41. Oh, do I have to draw it all?
Yes.
Now I'll write it all again. Why, when you have your book? F prime of -1 is equal to F prime of 1 is equal to 0. This should tell you that at -1 and 1, the slope should be 0. There should be a horizontal tangent. Now it says the first derivative is positive from -1 to 1. That means between -1 and 1, the graph is increasing. The graph should be going uphill. The first derivative is negative for x is less than -1. And the first derivative is positive for x is greater than 1. This is child's play. Okay, here's the x-axis. It doesn't really matter where the y-axis is. Okay, so here's -1 and 1. We have a graph. So when x is less than -1, the derivative is negative. That means the graph has to be going downhill. So we need a graph going downhill. Between -1 and 1, the derivative is positive, so we need the graph to go uphill. And then from 1 to infinity, it says the derivative is positive. So we need the graph to be increasing some more. So we need a graph that looks something like this, but then the slope at -1 and 1 gotta be 0. So this one's pretty easy, right? Like this. Right? The slope is 0 right there. And then now, what about here? Well, you gotta make the graph kind of flatten out, right? So this, see how it's increasing? It's going uphill, then it's going uphill some more. So any graph that looks something like that.
Do you wanna be in my picture, Mr. Parker?
No.
Oh, he's smiling.
Thanks.
You don't even smile in your yearbook photo yet.
No.
Why not?
I don't know, sometimes I do.
No, you don't.
Yes, I do.
That's a lie.
I don't lie. Okay, somebody said 50 something.
55. 55.
It's a multiple choice.
I know, but I don't know how to get that.
Okay, now it says antiderivative. What is an antiderivative? It's the reverse of the derivative. Now, right now, it's not too critical whether you can find an antiderivative, but later on, it's like super important. So it says, of which of the following functions is an antiderivative of that? Well, if you don't know anything, why not just take the derivative of each of those 5 functions and see if it comes out to 1 over root x? Right? That's one way to do it, but that's kind of slow. Another way would be to think, how do derivatives work?
Checks the whole.
Isn't this the same thing as x to the negative half power? Mark, you have a question?
Tara wanted you to, I think, you know how she forgot her homework?
Who?
The other day, Tara.
Yeah, she was supposed to come and show it to me.
Yeah, she has it, it's right there.
Careful.
She's supposed to come on her own.
She is the North
Driver.
Western.
Strike. What?
Oh, put it on the board, she's never gonna
No.
finish.
I'm talking to her on the
Just put it
camera.
on the board.
Okay, so how do derivatives work? Like if you have a function that's x to the nth power, how do you take the
What's
derivative?
her name?
N x to the n minus 1, right? The power comes down 1. So if this is the function you want to find the antiderivative for, in other words, if this is the derivative, what would be the original function? Well, wouldn't the power have to be 1 bigger?
1/2.
Yeah, so what happens when you add 1 to that? You get a half. But when you put the number in the front, it has to cancel out because look, the coefficient there is 1. So what number do I have to put here in the front so that when I put the 1/2 down, it cancels it out?
2.
2. So is this the antiderivative?
Yes.
Well, this is an antiderivative
And antiderivative.
because there's an infinite number. Is this the only function where if I took the derivative, you get this?
No, 4x to the
What about
1.
this? What if I did that? What if I took the derivative of that? Would
It's the
you
same.
get this?
Yeah,
Yeah, what about this? Minus 7.
yeah.
Yeah. So, what should I put then?
Minus 10.
What does the book say?
Minus 10.
No. Plus c.
Oh.
Where c is any constant, because when you take the derivative of a constant, you're gonna get 0, right? So the answer gotta be,
E.
I'm looking at it,
E.
E.
Movie.
No, we gotta learn.
Do you want to be in my picture?
No.
Can I learn something new?
No, somebody gave another number. You gave another number. What?
56.
56. All the following functions satisfy the conditions of the mean value theorem from -1 to 1, except, now in order for a function to satisfy the conditions of the mean value theorem, it has to be what?
Smooth and continuous.
Yeah, differentiable. Differentiable is the word. So between -1 and 1, which of these functions are not differentiable?
B.
Okay, so A, sine x. Okay, come on, we know what,
Yes, it's sine. It's
no, it
it's
doesn't.
good.
We know what the graph of sine x looks like. It looks like that. It's always smooth and continuous. Between -1 and 1, that would be between here and here. It's nice and smooth and continuous, so that's not it. Okay, what's the next one? Sine inverse x. Some of you forgot what that graph even looks like, yeah?
Yeah.
Maybe it's
Remember?
not.
I don't think
I don't think it's B.
No, I want to draw the graph
It's
for
not
you.
B.
Sine x.
That's all.
The graph looks like this.
That's also smooth.
So between -1 and 1, yes, it's nice and smooth and continuous.
It's probably
Although I'm-
C or D.
I'm pretty sure over half of you cannot even draw that graph. C, C, x to the 5/3 power.
That's a toughie.
Okay, now Mr. Brook, I don't know what the graph looks like. Okay, you know what? If a function's gonna be differentiable, that means it has a derivative. That's what differentiable means. So another way you can do this problem is take the derivative. Like, what's the derivative of sine x? Okay. Between -1 and 1, is there any place where it doesn't exist? No. What's the derivative of sine inverse x? Do we remember that? 1 over square root of 1 minus x squared. Between -1 and 1, are there any places where it's not differentiable? Okay.
How do you graph that?
Well, just look, the only numbers, okay, what, look at the graph right there. Okay, anyway, take the derivative of this. 5/3 x to the 2/3 power.
Wait, I have a question.
Yeah.
Is it including -1 and 1? Because wouldn't be.
Okay, the
1.
function has to be differentiable from -1 to 1. But the value of c that you find has to be between -1 and 1.
Okay.
Okay, anyway, so if you took the derivative of that, you get this. Is there any place where it doesn't exist? No. Okay, we just keep on going. What's the next one? D, x to the 3/5 power. What would happen if you take the derivative of that? You would get 3/5 x to the, no, you gotta be able to subtract 1 from that. -2/5. Is there any place where this doesn't exist?
Yes.
Yeah, it's 0. Because negative exponent means, this means 3 over 5 x to the 2/5 power. So when x is 0, it's undefined, right?
Oh.
Okay, but let's just go to the last one, e, which is x over x minus 2. Now, we know this is a rational function. This graph is always continuous except at x equal 2 because there's a vertical asymptote there. In fact, let me draw it for you. In fact, this is good review. How do you graph rational functions again? The 4 steps I taught you? X-intercept. Y-intercept. 0. Vertical asymptote. X equal 2. Horizontal asymptote. If the degree of the top and the bottom are the same, you look at the coefficient. So y equal 1. The graph looks like this. So, between -1 and 1, between here and here, look, the graph is nice and smooth and continuous. So, the only one that isn't is this one. Yes.
What if you plugged 1 into D?
Second.
No, between -1 and 1. Okay, next. What about 54? That's an even problem. Nobody wants to ask that? That looks like it's going to be on the quiz. You guys, everybody could do it?
It's
Warner?
B.
Last time we got B.
54? Everybody got it?
Yeah, B?
Yes.
Huh?
What was it?
Well, then how do you know if you got it? Let's do it.
Let's do it.
Cool. At the very least, people, let's see, at least last year they were smart. Every time there's even problems, they write it on the board so they can do it. But not this class. I want to just get it wrong and take points off. When you check homework, Mr. Parker.
If I do a book checking, you're extra.
Okay, how do you take the derivative of e to the
E
box?
to the box times the derivative of the box.
Okay, so you get e to the box times the derivative of box, which is 3x squared minus
How
12x.
would you get B?
Can that be factored? Can that be factored?
Yes.
You bet your sweet Vicky you can. So I can factor out a 3x, and what's gonna be left?
X minus
It's
4.
stupid, but it works.
Okay, now, can I make a number line for this? Now, if I were to make a number line for this, what goes on the number line? 4, 0, and what makes this 0? This is the point of the whole problem, people. Nothing. E to the gorilla is always positive. Think about it. What can I plug in for x to make it come out negative?
Nothing.
Nothing. Here, look. Let me draw the graph of e to the x for you again. It looks like this. Here's the point 0, 1. See how the graph is always above the x-axis? It's always positive. So e to the gorilla is always positive. So in terms of making your number line, it's not even there. So basically you're just making the number line for this, which is plus minus plus, right? So what, I don't even know the question. The question is asking, when is the function decreasing? When its derivative is negative. Well, when is the derivative negative? Between 0 and 4. And then you just pick out the answer, which is B. See, that's exactly what I mean. The way the book defines decreasing is, it's when the derivative is not positive. But I don't believe in that. A function is decreasing when its derivative is negative. So this is what I think the correct answer should be. However, on the AP exam, they sometimes do this, and you just have to pick out the best answer, so you would pick that answer. You know what I'm talking about? Even though this is the correct answer, you gotta pick the most correct answers. Pick that. All right, so is that it?
For it to be 4, is it okay if you like use natural on both sides?
No.
How'd I get the right answer?
No, just go e to the box is e to the box times the derivative of box. Don't natural log both sides. I know you've got the right answer, but the only time you should natural log both sides is if this and that are neither of them is a constant. That's when you natural log both sides. Okay, today's assignment, easy. All you gotta do now is make a number line for the second derivative. So tonight's homework, this is what you're gonna do. Take the first derivative, you make a number line. Take the second derivative, make another number line.
Mr. Parker, I feel like you're struggling to talk.
Are you having a stroke?
Oh my god.
What's the thing you're supposed to check for?
Speech.
No, but there's like an acronym for it.
Face or something like that?
No.
I don't know.
I know what you're talking about.
Yeah, there's an acronym. Come on, somebody.
It's called
Google it.
No, let's just do this. Okay, so what did we learn last time? If the first derivative is positive, what does that imply? The original function is increasing, right? This is what we learned. If the first derivative is negative, that implies
Fast.
the first
It's
derivative
fat.
is, say that again?
Why?
Fast.
F-A-S-T?
Yeah.
Face,
Facial drooping,
Facial.
arm weakness, speech
Speech.
difficulties, and time.
Your face is
and what does time mean?
Like distorted time. Like they don't know how long they've been somewhere or something.
Are you sure you're just making that up? I think
It said
I
time.
feel like he's
I
looking-
think-
he just
I don't
looked
think
it up.
time actually
I
slowed.
don't-
I think time is get to the hospital quickly, right? No.
Yes, time to call 911.
There you go. Okay, what if the second derivative is positive? What does that mean? That means the original function is
Mr. Parker, can you
concave.
raise your arm
up.
fully?
No.
What
If
about
the
your
second derivative, no,
Can you
I'm
kick
a
the
little
board?
slow today because I had a rainbow drive-in plate lunch. Made me kind of, sluggish. Especially on the macaroni salad and the brown gravy and.
Oh, wait, weren't you supposed to go with Reese?
No, I'm gonna go with him.
No, but remember you
F
said you
is
guys get the same
concave
thing.
down.
Where is he?
He's at the northeastern thing. With Ted.
Okay, so this is the new stuff over here. If the second derivative is positive, the function is concave up. If the second derivative is negative, the function is concave down. Now, with these two things, we can draw really accurate graphs now. Okay, I'm going to give you two examples, a simple one and a hard one. Let's start with the simple one. Y equals, this is the one I gave you last time too, x cubed minus 3x plus 2. Okay, so what we need to do is we're going to draw the graph labeling all important points. Okay, so here we go. First step, so every single problem of tonight's homework, this is what you're going to do. Take the first derivative. 3x squared minus 3, and then you make a number line for it, so you need to factor it completely. So you factor it, and unless of course it's a calculator problem, then you make the number line on the calculator. And do not forget to label your number line. I'm going to be checking for that on Thursday's quiz now. No label, no points. Plus, how do I know it's plus minus plus?
Cause it's a cube.
Who's a smart?
Okay, now what do I need to write underneath to get full credit?
Y.
Y is increasing.
Can I write white ink?
If you have a legend.
Oh
my god.
What?
I'm gonna
That's
tell you, on the AP
ridiculous.
exam, they don't want any abbreviations. So if you are gonna use abbreviations, you better have a legend on the paper.
Can you do like smiley face legends?
Can you just do it what I tell you so you can get a 5, so I don't have to come to your house and strangle you? Y is decreasing.
Smiley face is Y.
Y is increasing. So you can clearly see from this number line, look, if the graph goes up and then down, isn't this a maximum here?
Yes.
And from experience, is this a local maximum or an absolute maximum?
Local,
How come?
cause it's plus on the right, then there's no domain.
Okay, so local maximum will occur at -1 comma something. How do I figure out the y
Plug it
coordinate?
in.
You plug it back into the original. Do not plug it back into the derivative, because if you plug it into the derivative, you're just gonna get 0, because the derivative tells you the slope, right? So if I plug in -1, what do you get? -1 plus 3 plus 2,
Oh, just.
4. And then what about this point right here? If the graph is decreasing and then suddenly it increases, this will be a local maximum.
What? Wait.
What am I talking about? I blame that on the plate line.
Fast.
Local minimum, 1 comma something, and how do I get the y coordinate? You plug it into the original, 1 minus 3 plus 2.
Zero.
Hey, it's on the, angel.
Thank you.
Remember you said?
He's an
Remember that day?
angel?
No, remember on the
Bingo
on the
man.
movie, no,
Angel.
you dig the hole, you dig out the sand. The sand is a positive, the hole is a negative. Remember that?
Yeah.
Zero in Spanish.
Come on,
Found this on.
come on, nethead, fill the hole, fill the hole. And then he said 0.
Zero.
You guys don't remember that?
I do.
And then his friend looked at him and he was mad because he trying to be smart. Okay, so we already did that already. Now we do second derivative. So second derivative, now, when you take the second derivative, all 3 of these are the first derivative, right? Which one is the easiest to take the derivative of? The first one. Because you don't want to use product rule if you don't have to, right? Just do the first one. 6x, finished. So we make a number line for that. See how you got? Now do you understand why you have to label the number line? Because a lot of your problems you can have more than one number line. It has to be labeled if you want to get credit. What goes on this number line?
Zero.
0. Plus, minus.
Wait, Mr. How do you know if it's local or absolute?
Because this is a polynomial function, it's a cubic. It goes like this. Is this the highest point on the entire graph? No, because it keeps on going up. And same thing, is that the lowest point on the entire graph? No. That's why you have to know about the behavior of functions. What? Okay, can we, now, what did we just learn today? If the second derivative is negative, what does that mean?
Concave down.
Y is concave down now. This is the way we write it at ELN. Y is concave down. See that?
Wow.
See that? Concave down.
That's my.
Yep. That's not lame. Math teachers love this when you correct it on the AP exam. And then right here, if the second derivative is positive, that means y is concave up. You know, because most students, you know what they do? They just go, y is concave down. That's like so boring. That doesn't tell you anything. But look at the visual.
It tells me that concave is down.
Now, before, on the old AP exam, you could just do this. But not anymore, because they want you to demonstrate to them that you know the
Legend.
connection between the second derivative, the sign of the second derivative, and the first derivative. So, did anybody read the book? Right here, you see this point right here?
Point of
When-
inflection.
Oh, very good. If you have a point on the graph that changes concavity, see how it went from concave down to concave up? We call that a point of inflection.
I did read the book.
Very good. So there is a point of inflection at 0 comma something. And how do I figure out the something?
Plug it back in.
You plug it back into the original, and that's a dot, that's just 2.
You want to be in my picture? This is a.
No, don't take it yet. Let's just draw, no. Now, here's the whole thing. Now you gotta draw the graph, an accurate graph. Okay, so let's do this. We have a local maximum -1, 4. And we have a local minimum at 1, 0.
Mr. Park, did you see any students when you went to go get lunch there?
No, I went right after period 8, so there was nobody there sitting. And a point of inflection at 0, 2.
Oh.
Okay, so here we go. This is a local maximum, point of inflection, local minimum, and we know what the graph's gonna look like. So look at this thing. See how it's concave down? And then now it's gonna be concave up, but then this has to be a local minimum. See, so with these tools, now we can draw really accurate graphs. Of course, this is a really simple one.
Bring on the complication.
Okay, now let's do one harder problem and then we'll start the movie. Now, I'm gonna do one of the problems from the homework because every year they make me do it anyway. It's gonna be number 20, which is the same problem I did last time, but you guys probably don't remember yet. Okay, number 20, let's do this quickly. X. In fact, you know what? I usually give this on the quiz again, even though I did it in class and all hell breaks loose. You guys remember me doing this last time?
No.
Yeah.
Some people do,
Yeah.
because I read some of them took notes.
You
Okay, so
decided
here we go.
to
We're gonna
push
take the
or not.
derivative, make a number line, take the second derivative, make another number line. Here we go. First derivative, ooh, it's a quotient, I gotta use the quotient. Low, d high, minus high, d low, all over denominator squared we go. Okay, now you gotta simplify that. Now if we simplify the top, what is that? X squared plus 1 minus 2x squared. That's 1 minus x squared all over x squared plus 1, right?
Right.
Squared. And then if you factor it completely, now does this look familiar from last time? Of course not. So we make the number line. So what goes on the number line? -1, 1. What about for the bottom? What makes them?
Nothing. It's irrational. You can't put eyes on the
Imaginary,
number.
imaginary.
Imaginary.
Okay, calm down. Irrational. Okay, if you plug in a number bigger than 1, you're going like 2,
You got
1 plus
me.
2 is positive. 1 minus 2 is negative, and the bottom is always positive because it's squared, right?
Yes.
So,
Negative.
negative, and then how do I know they're gonna alternate like that? Because you got odd powers on these puppies. So, y is the, now, here's something that can save you time. If you wanna put this on your homework, this means decreasing. That means increasing. This means concave up. I can't abbreviate, yeah?
Instead of writing means, can you write equal?
This means
I gotta say the most time.
concave down. So if you want to save time, you can put this at the top of your homework and just do that all the time.
So is that a no? Means equal. Oh, means equal.
Only numbers, okay, we're AB. Okay, you know what, we're AB, I'll let you do that.
Yes.
Although only numbers can be equal. You can't have a symbol be equal or something. Okay, so you can just do this, look. Y is decreasing, Y is increasing, Y is decreasing. Now I know what some of you are thinking. You're thinking, Mr. Park, why don't I just put this means Y is decreasing so I don't even have to put the Y? Some of you are thinking that, aren't you? But what if instead of Y, what if they put f of x here? Then you gotta write f is decreasing. Because there's no Y defined in this problem. So there, that's why. That's why you don't
Oh,
want to do
that's
that.
why.
That's why you don't want to put the Y.
Funny guy.
It's not funny. So right here. Now, remember from last time, is this an absolute minimum or a local minimum? No, you guys forgot it. That's
Hey, let
absolute.
me check.
That's an absolute minimum. Why is that?
It's on
Because
the
there's a
back.
horizontal asymptote here.
Pterodactyl.
Doesn't exist.
Let me draw the graph again for those of you who forgot. Okay, it's the x-intercept, the y-intercept, no vertical, horizontal is y equals 0. So it looks like this.
Pterodactyl.
I had you draw this, you know when we did the review
Oh,
in the
right.
beginning of the year? That is an absolute minimum. That's the lowest point on the entire graph because there is a horizontal asymptote there. And how do you get the y value? You plug it in and you get negative half. And then according to this number line, there's gonna be an absolute maximum here. So absolute maximum at 1 comma something. How do we figure out the y coordinate? You plug it in here, you get 1/2. Okay, now you gotta do second derivative. Now, which one you wanna take the derivative of? This one? I don't think so. So it's either this one or this one. Which one looks easier? A or B? A. So here we go, baby.
That's
Okay, so that's a quotient. I'm gonna have to use quotient rule. Low D high minus high. That's not high. Start all over. Low D high minus high D low. Now, how do you take the derivative of the bottom? That's box squared. 2 box to the first times the derivative of box. All over denominator squared we go. Okay, now I'm sure all of you can do that, but now you gotta simplify it into factored form so you can make a number line.
Let's do it.
And I keep telling you that's the hardest part of the problem. Well, look at the numerator. What can I factor out from the numerator? I can factor out
X plus one.
a 2, an x, and an x squared plus 1. Now, does anybody have foresight here?
It's gonna cancel.
Like, should I factor out a negative sign or a positive sign?
Negative.
You're just guessing.
Wait, why would you factor out a positive?
Okay, here, let's just do this, okay. If I factor out a 2x and an x squared plus 1, what's gonna be left?
Negative.
Negative
X plus one.
x squared plus 1 minus, so if I factored out that and a 2x, what's gonna be left? Just these two, right? 2 times 1 minus x squared. Correct? All over x squared. So did I make the right choice, or should I have factored out a negative sign?
No.
Some of you still don't even know. Can I cancel this x squared plus 1 with one of those right there? I
Yes.
just did. And then if you simplify what's in the brackets, you get negative x squared minus 1 minus 2 plus 2x squared. So that comes out to
X squared.
minus 3. Now, do you want to just leave it like that, or do you want to factor this into x plus radical 3 and x minus radical 3?
Leave it
No
like
need.
that.
Okay. Everybody understand that there's going to be a plus or minus radical 3. Okay, now let's make a number line. Woo! What makes the top 0? 0, radical 3, and negative radical 3. What makes the bottom 0?
Nothing.
Nothing. In fact, the bottom is always positive, so you don't even have to worry about it. Plug in a number bigger than radical 3.
Plus.
2.
Okay?
Plus.
Plus. And then how do I know? See this, every time I do this on the board, I just write this and then you just copy it down, and then when it's time for you to do it on your own on the quiz or test, all hell breaks loose, yeah? Anyway, so what does this mean? If the second derivative is negative, that means y is concave down. Y is concave up. Y is concave down. Y is concave up. So, is there a point of inflection? Let's put it over here. Point of inflection.
Negative.
Is this a point of inflection? Does it change concavity there?
Yes.
Yeah, so there's a point of inflection here. What about at 0? Does it change concavity?
Yeah.
Yeah, so at 0. And then what about at radical 3? Does it change concavity?
Yes.
Yeah, from concave down to concave up. So all 3 of those are points of inflection, and how do I figure out the y
Plug
coordinate?
it into the
You
first.
plug it back into the original. So you're going to get negative root 3 over 4. 0, that one's easy. And positive root 3 over 4. And does that make sense? Look, this is just a sketch of what we did, but okay, here's 1 and negative 1, right? Oh, that's 1 and that's negative 1. See how we have our maxes and mins? But then at radical 3, right here, look, it went from concave down, concave up. See, it all makes sense now, look, right there. There's the absolute minimum. And then at negative root 3, right about there, we have a point of inflection. See how concave up, but then now it's concave down.
Yay. Movie.
Good work, Mr. Park. Okay, so yes, this is significantly, like if you have a nice polynomial, it's all easy, right? But then when you have stuff like this, or trig functions, there's a lot of work to be done. Okay, and I don't know if you guys noticed, but on the assignment sheet, we're gonna skip 5.4.
No, aren't we doing it later?
Yeah, we're gonna do it later. So after this, we're gonna skip to section 5.5, and then we're gonna have a test just on those 4 sections. And then we're gonna go 5.4, 5.6, and just have a test on those 2 sections. Because those are more difficult, those are all word problems, which students don't typically like. All right, let's get into movie configuration. Well, you don't wanna give this, driver? Who should I give this to?
Mark.
Give it back to Park?
Sounds good.
Are you gonna see her next period?
Oh yeah.
Oh yeah.
Oh
What is,
yeah.
what's that supposed to mean?
No.
No.